So I have opening mine up right now. Okay, so 3 is we assume sigma is unknown.
Yeah, sigma is unknown. So have you ever been out to Utah during like late September, October, the Halloween season?
Yes.
Okay, so you've seen. Were you able to get into any of the Halloween stuff out here?
You
Or
know,
when
I
was it?
haven't. I've gone to quite a few in Idaho, and like, okay, here on the East Coast, like they don't have stuff like that. Like they don't have haunted houses like they do in Idaho and Utah. And like I've never been to one in Utah, but I have a lot of Utah friends and they always talk about the haunted houses. And so and how great they are. I'm like, man, because this October I'll be in Virginia. I won't be out there, so I'm kind of disappointed because it's really there's nothing like that out here. So
Yeah, because yeah, Utah consistently is voted like some of the scariest haunted houses in the country, and I have a
oh
theory
man,
on it. Like I have a theory on it that I share with people. Because the thing is,
what's your
like the haunted houses. Well,
uh-huh.
first off, Utah, or what we think of Utah is essentially Salt Lake and Utah County. Like
Uh-huh.
I think it's like what 80% of the population lives within those two counties,
Yeah,
which is just like a 50-mile radius.
yeah,
So the vast majority of people live within that radius. And Utah is crazy educated. Like you may not think it, but it's just like the number of young people in Utah who go to college is
mm,
way above the natural average. And
yeah,
so like just within Utah and Salt Lake counties, you have the U of U, UVU, and BYU.
yeah,
UVU is like the fastest freaking growing university out there. Like holy crap, just checking it out every year or so. It's just like there's new buildings everywhere.
yeah.
And then BYU is just straight up the largest private university I think in the world. Like it's just huge. And
Awesome.
so you have in this like 50-mile radius 3 really big universities, and then you have all of the things like Stephen Henniger's and Salt Lake Community College and all that kind of stuff.
Hmm.
So you have a student population of probably, let me think, it's got to be like over
I was
100,000.
gonna say over 100,000 easy.
Yeah. And that's just within a 50-mile radius.
Yeah.
But then what makes Utah even more unique, because the college students, that's what haunted houses are really geared towards, because they're too scary for little kids, and then older people don't really get into them. So they're
Yeah.
really geared for college students.
Hmm.
But the thing is, what makes Utah even weirder is that not only are we super educated and we have a ton of college students here, uh, that like a large majority of them
Hmm.
don't drink.
Yeah.
And so you're going to a haunted house that's directed at like 18 to 25-year-olds who are sober, which means that you really have to step up your game. And so because of that, Utah has just got a ton of really good haunted houses.
Yeah.
And then an entire Halloween culture has just kind of built around that, to the point that like you'll have like Thanksgiving Point with kind of the non-scary things and just the festival things and hay rides and pumpkin patches and all that kind of stuff to make it entire family friendly inclusive.
Hmm.
But yeah, like because of that, Utah Halloween basically lasts from like the middle of September until actual Halloween.
It's
And I
crazy.
love that so much.
Yeah, I love haunted houses, but let me tell you, I am such a scaredy cat. Like, I'm the one that's freaking out, screaming on the top of her lungs because, like, I know they're not real, but like, I get into it. So I'm like, because I want to be scared, I want to feel that thrill. So I guess I let myself like get into it. But man, I am like screaming, running, like, oh
I
man.
remember, no, those are the people that the players love. I'm like that too. My little brother Alex, we went to a haunted house. It was movie themed, And so it's like every room you walked into became a different movie, from like The Shining to the Texas Chainsaw Massacre to the Ring type thing, you know?
Uh-huh.
And one of the rooms that happened was, and it was so funny because the girls were tiny, but it was The Shining. And so it's just these two girls dressed up like similar to each other.
Uh-huh.
And they just cornered my brother and just started screaming at him. And he was seriously just stuck in a corner. And it was just like, he couldn't like get up and like push him out of the way, even though he's a big guy and could obviously do that. But it's like we got separated from the group, and when we finally found him, he was seriously just stuck in the corner with these two girls just screaming at him. Like, people in Utah, we love our haunted houses, and so the people at the haunted houses really get into it. Like, it's just
I would, yeah. Oh my gosh. They always pick on me. They can like sense my fear and so they just like go after me. It's fun. I really enjoy them. It's like it's so fun. I love it. But
I know, I'm so excited. This is my first Halloween in Utah for a while. I spent last year in Oregon
Mhm,
and then a few years in Texas.
mhm.
And yeah, Texas, like, it was Halloween was on Halloween, and kind of the same up in Oregon. And I'm so used to Utah. I'm like, what's going on with you people? So
Yeah.
the fact that it's happening like now that I'm back in Utah, I'm so excited because one of my favorite traditions, and I haven't been able to do it for a few years. Um, have you heard of Odyssey Dance Theater? I'd be surprised if you had, but maybe you had, being up in Idaho. Okay, so um, it's a dance troupe in Utah, and
Uh-huh.
every year they tour around the state, all the way from up in Logan down to Tuacahn and St. George. So they basically start north and just go south every weekend. And what they do is it's a dance show, which it's a dance show incorporating basically every genre. So everything from hip hop to ballroom to stomp to tap, like they do pretty much a little bit of everything.
Yeah.
But the one thing is that everything is Halloween related. So
Ooh.
like the kind of hip hop stomp stuff where it's just kind of irregular movements and stuff, uh, would just be like the zombies just kind of flailing and stuff, or like a werewolf chasing its victim type thing. Like the ballroom, the way the ballroom works is it's Frankenstein and Bride of Frankenstein, and they're doing a
Uh-huh.
ballroom waltz, but then like halfway through, Frankenstein, not knowing his strength, accidentally breaks her neck. So he has to finish the dance with this limp body, and it is amazing how flexible that woman is. Like,
Yeah.
he's just moving her and contorting her, and it's just like, how the heck? Because he'll like tip her over, like touch her head to her foot and stuff. You're like, how can she do that?
Oh my gosh.
But it's super fun because it's just basically a dance review where they just do kind of all the different genres, but everything is Halloween themed,
Yeah.
and it's just super fun. Like one of the funnest things, because just speaking of about haunted houses reminded me of it, is that they open and close with Michael Jackson's Thriller.
Love it.
So there's a lot of people dressed up as zombies, and before the show starts and during intermission, the zombie dancers are just wandering around the mezzanine and just kind of the lobby and stuff. And it's so fun because, as much as I love the haunted houses here in Utah, those guys are phenomenal because they're practically contortionists. So it's not just someone in creepy makeup lumbering towards you. It's someone who's like, it's weird. Like, I swear, this one time I was walking up the stairs and I saw this just head, but it was like upside down, and girl. It was this girl who was at the top of the stairs, basically walking upside down like a crab type thing.
Uh-huh.
And so she would just basically perch at the top of the stairs, and when someone was coming, she'd come around and
Oh,
just stare down at you. And it was just like so unnerving.
that is so creepy. I couldn't. I'm getting freaked out just thinking about it. I'm like, yeah. Oh my gosh.
But anyway, I don't know why I went on that tangent, but I'm really excited for Halloween this year.
I
So,
am too. It's okay. Oh man.
okay, question 4. Oh, this one's easy. Is Sigma known?
It says not known, so.
Yep, yeah.
Okay.
The value of t. What's the equation to solve for t?
The equation is, I don't have it memorized. It's
Pretty much the same as z.
yeah. Let me get my calculator. Okay, so it's gonna be 11 minus. Did you get 1.5?
Something else, but let me double check something real quick.
So, for let's see. For our mu, do we use 8?
Yeah, because that's our null hypothesis.
Okay, that's
so
what I
mu
thought.
would be 8. What would you get again?
1.5?
I got something wrong. Let me try again. I got 1.5.
Okay. Okay.
Long string.
Dang, I should have saved, because they gave us a ton of different Excel sheets, like the baby boom, the body temperatures. I should have saved all of them. I wouldn't have to re-enter them in. It's okay though. Mine won't. On your computer, can you copy the numbers from the quiz?
Oh no, yeah, with the way they set up the quiz, you
Can't
can't
copy.
highlight things. Yeah,
Okay. Okay. Guess
I
I have
think
to.
I'm not
I think it
positive, but
might still be in my downloads. Yes, it is. So that's okay. Sorry. Just wanted to make sure I got all the right numbers. Okay.
You got number 6?
I finally got the numbers entered into
Okay, no problem. I'll give you a second.
Okay, null hypothesis is. I totally did this earlier. I should have saved it. But, um, okay. What is. So for the type of test, oh, it says less than. You put less than, right?
Wait. Sorry, I got distracted.
You're good. 'Cause it says
Okay,
the alternative hypothesis is less than, so you'd put type of test is less than.
where's it asking that?
Um,
Oh, you're using that Excel sheet that they gave us.
yeah. Is that what
Okay.
you're using?
No, I'm just using a blank Excel sheet.
Oh, that's probably easier.
If you have, because that definitely helps, but you can get the same results just from using because that Excel sheet is if you don't have access to the student's probability. But since I have that pulled up, I'm just using a normal Excel sheet.
Okay, so I can use this though, right?
Yes.
Okay. I think I'll use it for now just because I used it for the other samples on the homework, so I guess I'll just use it.
My only thing, just a heads up, is
Uh-huh.
familiarize yourself with the new applet.
Uh-huh.
Just because I'm not sure if that
We can
sheet
use this for the
on the test, yeah.
okay.
So just make sure you're familiar with both.
Yeah. Okay, what was there? Okay, so that took me a minute. So
No
for the
problem.
mean, I got 98.22.
Okay, that's what I got. Another reason why I like to use blank Excel sheets,
Yeah.
which might be good for you, just depending on the type of learner you are.
Yeah.
Using blank Excel sheets means that I have to type in the equation. What I do is I put in all of our given information, and then I'll do a cell and have that equal to, and then I'll type in the equation. And so it forces me to type in the equation for like margin of error and standard deviation and that kind of stuff.
Memorize.
Exactly. Like I realize that's not super important because she lets us have a page of notes taking into the test.
It's always,
But
yeah.
it's nice just having that just off the top of your head, so you don't have to, you know.
For
But
sure.
whichever one works best for you. That's why Sister Cook is giving us multiple options. She wants to make sure that no one's left behind because they don't understand the technology behind it, or the math is just too stupid going through it over and over again.
Yeah.
Which I appreciate, the fact that she's just kind of like, whichever one works best for you, as long as you understand the concepts. I don't know. I don't care if you're weak with math or if you're weak with technology. Just whichever one helps you the most, just go ahead and use. And I really appreciate that.
Yeah, it is
'Cause
nice.
yeah, because some teachers are like, it's my way or the highway.
I know, it's such
And you're like, you've been teaching this for longer than I've been alive. Like, there's no way that I have the same understanding as you.
Oh, that's funny. Okay,
Okay.
so for standard deviation, I got 0.922.
Okay, that's what I got.
So let's see. For my T-score, I got negative 1.843.
Okay. Check something real quick. Okay, what's the T-score you got?
Um, Negative 1.843. Did you get something different?
Yeah, and this is a conceptual thing that I'm just actually been having a little trouble
Mm-hmm.
with because Sister Cook hasn't really explained it in the
Yeah.
text, or at least I didn't see it in the text.
Mm-hmm.
With this one, because you remember how in the last section we could calculate our z-score,
Mm-hmm.
but in this case, we're given a level of significance of 0.05.
Yeah.
So instead, we already know what we want our t-score to be. So, for example, in the last section, if we were doing a 95% confidence interval, our z-score would automatically be 1.960. If we were doing a 90% confidence interval,
Mm-hmm.
it's going to be what, 1.687, 675, I don't know, something like that. And
Yeah.
then the other one was like 2 point something. And so this one, what is the t-score? If you calculate it out real quick, I'm pretty sure you got the right answer. But if you go to the applet and if you put in degrees of freedom and an area under the curve of 95%, it gives something different. But when I was doing the homework earlier, it was you use the applet because alpha was already determined. So I'm trying to figure out which one they want.
Let's check this out. So for the T-score, what did you put in? The applet?
So to the applet, at the very top, it asks for our degrees of freedom.
Yes.
And our degrees of freedom is 19 because our sample size is 20. And degrees of freedom is just sample size minus 1.
Right.
Then after 19 is in there, I put an area of 0.95 because that's our confidence interval, and that gives me a z-score of 2.093.
Yeah. I do not know.
That's what I'm trying to figure out. So just experimenting based off of, trying to think, this t-score. If we put this t-score in, so degrees of freedom of a 19 with a t-score of 1 point, what did you get?
Negative 1.843.
Okay, yeah, that's what I got. So if you plug that in, then that gives us an area under the curve of 0.9190 or 91.9%. And is it asking for, probably should have read the question fully. The alternative hypothesis, I'm sorry, I got distracted. I really should have just read the question more thoroughly. Okay. So our alternate hypothesis is that body temperature is greater than 98.6. So we are not looking for a confidence interval. We're simply looking to see if the data we've got, if our P is smaller than our alpha. So that's what we're doing here. We're not dealing with confidence interval. So the calculated t-score is exactly what we need.
Okay, so the negative 1.843.
Yeah.
Okay. And then the p-value I got 0.040.
Well, hold on a second, because it's actually asking. Oh, is less. For some reason, I thought it was greater than.
Yeah, it should be less than.
Less than. So if it's less, we're looking at the left-hand side, which is 0.4050, right? Okay.
Okay, so p-value.
So our p-value is less than our alpha. Do we reject the null hypothesis or fail to reject the null hypothesis?
We reject the null hypothesis.
Okay, perfect. Okay, and I guess that's what this question was trying to show, because you know how the threshold that we have on Tuesday was, if we're looking at alpha of 0.0, like 0.05, then basically we want a z-score of 1.96. You know how, and that's 2 standard deviations pretty much.
Yeah.
This one, we have a t-score that's less than that. It's just 1.843, but we still got a p-value that was significant. So I'm pretty sure that this is showing that how important the degrees of freedom are with this. Because we had a large enough sample size, even though our t-score was actually smaller than the 1.96, it's still considered significant. So does that make sense?
Oh. Huh. Okay. Yeah.
I think that was the point of this question, was to kind of show that here are degrees of freedom, and this is why we use degrees of freedom. Because when we don't have sigma, degrees of freedom can actually alter our results. Because, for example, 19 gives us something significant. If we do... If we change our degrees of freedom to 2, so if we only had a sample size of 3 and our degrees of freedom were 2, our answer changes from 4% to 0.1033, so 10.33%. So just by having a larger sample size, our results are more valid.
Yes.
Does that make sense?
Yes.
Okay, so that's what this question was about. Okay.
Okay, now the baby boom.
And this one was, yeah, that's, I think she had put up the way. Oh, I'm looking at something else. Okay, so she didn't put a link for the baby boom in the quiz itself.
I still had the baby boom one up from
Okay,
I was doing the homework, so.
give me a second while I re-download that one so I don't have to type everything in.
And it looks like she used 21 sample size or samples. I don't know if you want to count those or not.
Wait, say that again?
I counted 21 numbers.
So we're looking at weight, and it goes from 2 down to 45. Oops. That'd actually be 44. Are we looking at different sheets?
I'm looking on the quiz and the number.
Oh, the number. Okay, so this is from Baby Boom, but this isn't all the information from Baby
Yeah,
Boom.
I think we're just supposed to use the ones that are right here.
Okay, then that doesn't matter that I downloaded Baby Boom. Okay, so we're back to where we were. Okay, start typing this in real quick.
So I got, for the p-value, I got 0.905.
Oh, dang. You're a freaking speed demon. Give me a second.
It's the thing. It's already set up. I can't take credit to be.
What'd you get?
So for the p-value, I got 0.905.
Hmm. I think something else. Let me try using that one that she provided. question. So 40. Oh, I didn't change the null hypothesis. Okay. So you got a p-value of 0.995?
0.905.
905. Oh, the confidence is just 0.9. I didn't change it. Confidence level.
It's, I think, point
Oh,
99, right?
0.9. I read that wrong. I had a dyslexic moment.
You good?
It's still not changing my p-value. It's really weird.
Huh. So, yeah, so the confidence level is 0.99. The null hypothesis should be 40, and the type of test should be not equal to.
That's weird. What does the t-score say on your sheet?
Negative 0.121.
Okay.
Mine
Yeah.
could be wrong. I don't know.
No, I'm just confused because I'll show you real quick. What I have. So yeah, so if we have degrees of freedom of 20
Hmm.
with an area of not equal to 905, and I got the same t-score as you,
Hmm.
but for some reason I have the information here. Confidence 99, null hypothesis 40, not equal to, but I got a really tiny z-score, t-score, and the p-value is off also. Not as much for the t-score, but so that just has me. I'm wondering.
Oh, um, the column A, I have different numbers.
Let me delete these real quick because that's. I just typed the mean directly in here from what I got. Do you have a different mean and standard deviation than me?
Yeah, so my mean is 39 and my standard deviation is 36.97367 blah blah blah.
Okay.
Oh wait.
This is what I used for my mean and standard deviation and stuff. Let me double check, make sure I typed everything correctly.
Okay, so I caught something on my end. So for my n, I still had 20, and so I typed in 21. And that changed my p-value to 0.909025.
We should still have the same mean because
Yeah.
you just typed your numbers into column A, right? And it calculated the mean for you.
Yeah, I copied and pasted the numbers from the baby boom, but I only did the first 21, I believe. And it was the on the actual baby boom Excel sheet, it's the last column. Wait, hold up. So there's I can share my screen. This is what I have on mine.
That's weird. Yeah, I reopened it and now it's not doing the calculations at all. So
That's weird.
let me just make sure I ran it through. I typed everything correctly in the other one that I was using. Okay, what average did you get?
Average.
So yeah, the mean.
Oh, 39. Is that what you got?
No, I keep getting 40.04. Are you sure that you've got all of the numbers in there and that it's calculating based on all of them and not just some?
Let's check this out together. So my formula for this is A5 to A20.
Yeah, it should be
Oh,
to
wait.
A25.
Oh, look at that. And then this. Dang, there's so much to change. Okay. Okay, do you have it the same now or?
Okay, let me check real quick. Okay, so what was your mean?
So my mean is 40.047.
Okay, and your standard deviation?
36.3558.
Okay, now we're on the same page.
Whew, okay. We got this. Okay. Let's see. So number 11, our p-value will be 0.995. And 12, what decision do we make? So we failed to reject the null hypothesis.
Hold on a second. I have so many freaking pages open that I'm losing track of where I am. Okay. So let's get rid of the baby boomers. Oh, hey, Wednesday. Oh, there's my kitty.
Oh, hi,
This is
pretty.
Wednesday. Hey, Wednesday.
Hi.
You just wanted some attention?
Oh.
She is the most patient, sweet little kitty. Oh, such a good kitty.
I love cats so much.
Okay, let's see what am I doing wrong here. The man likes Wednesday. Yeah, this is what I was telling you about. Wednesday has to get hand licks in. And if she doesn't, she gets like panic attacks.
Oh.
I'll see if I can type with one hand Wednesday, otherwise I'm gonna have to throw you off my lap. Okay, what am I doing? What T-score are you getting?
Give me 1 second. Sorry, I typed in a different one. Okay, here we go. My T-score is 0.006. Is that what
Okay,
you
I think I
want?
see. No, but I think I see what I did wrong. Okay. So that was still on body temperature. 40. T-score of 0.006. So here we have degrees of freedom of 20 and a T-score of 0.006. And we are saying it is not equal to, so we are looking at both sides. Okay, so p-value of 0.9953.
Yes.
Okay. Okay, so we have a huge p-value compared to our alpha. So what do we do?
So we failed to reject the null hypothesis.
Yes. Okay. Now we are doing the same thing.
Change it to less than.
Yes. So if we're doing less than, we only care about 1/2 of the graph. And so what happens to our p-value?
It decreased.
Yes. And with our smaller p-value, does that change our overall conclusion?
Yes.
What's our new p-value?
0.502.
What is our alpha?
Alpha is 0.01.
So which is bigger, alpha or p?
Oh, P.
Yes, our p is, even though we cut it in half, it's still bigger than our alpha.
Okay, so we p-value is so we reject the null hypothesis.
When do we reject the null hypothesis?
Hold up, I'm having like a dyslexic moment.
No problem.
Reject when P is low, reject the null. So, okay, so we failed to reject the null hypothesis. Sorry.
Yes. Oh, no problem. Okay, now construct a 95% confidence interval. So now this one, rather than calculating our t, it says that we are doing a 95% confidence interval. So we don't calculate our t here. Instead, we are going to use the probability app to figure out what our t is. So degrees of freedom is 20. We are actually confidence interval. So that's going to be both sides of the equation. So the left and the right, but not the middle. And then we set the area to 0.05. And what is the t-squared that you got?
So what it, hold up. Okay, did you get 0.480?
No, I got a large T-score.
Did you get 23.499?
Not that high.
Okay.
Screen share with me, see it, so I can see what you're doing.
Okay. Let's see. Okay, so I have the app up and I also have this up. So 20 degrees of freedom
Mhm.
and 0.05 for the T-score.
Okay, we're actually trying to figure out what the T-score is.
Okay, and
So with the confidence interval, which sides of the curve are we going to be highlighting, or what areas of the curve?
um, I guess it depends what I was asking.
Well, it's a confidence interval, so that automatically tells us what it's asking for. It's looking for the upper and
Oh,
lower limits.
both sides.
Mhm.
Okay, so it's going to be 0.961.
Oh, you want to type in your area. Well, actually, okay, that's where we got confused. We did it in opposite ways. It looks like
Okay.
there's two different ways to do it. The way I did it was
Oh, this. Oh, so this. Wait. Uh. So 0.05 needs to go in the area.
yes, perfect.
Okay.
So 95% confidence interval means you either highlight the two ends and
Uh-huh.
put in 0.05, or what you can do is highlight the middle area
Hmm.
and do 0.95. So they're the same thing, it's just two different ways to do it. And it looked like you got it confused a little bit because you highlighted the ends and then put the
Yeah.
area as 0.95. But no, you have it perfect now.
Okay. So it would be negative 2.08, right?
Negative 2.08. Yes, that's what I got.
Oh, 8.
86. And then we can use that and we can calculate. Yeah, we should be able to calculate the rest of it out now.
So wouldn't 15 and 16 be the same?
Check this
Oh,
first.
wait, except for just positive, right?
Yeah, so at this point, we're taking our margin of error. So if you remember from Tuesday, there's 2 points of our confidence interval. There's the point estimation and the interval estimation. So the
Yes.
point estimation, which is just going to be our average, which is 40.04, 40.047. Yeah, that's going to remain the same. We're just going to take our margin of error and add and subtract it to that.
Okay. So we're adding or subtracting. So, okay, so we need to find out what the margin of error is first, right?
Yes. So now that we have the t-score, we can solve for the margin of error, which is the interval estimation. And then once we have our interval estimation, we can then complete our confidence interval.
Okay, let's see. Okay. So for the margin of error, we need to know the standard deviation, though.
The standard deviation of what?
Um, I don't know
Do
because
we,
it doesn't give us the standard. Because the margin of error formula is standard devi or sigma times z-score over the square root of n.
so when sigma isn't given, what do we use?
Oh, they gave us that formula.
Mhm.
Okay, let's see. Okay, so we just do um the mean, or yeah, minus t. Okay, okay, okay. Okay, I need help. So it does, they don't give us the, oh,
So when we're not using sigma, what do we use?
so we use the confidence, the formula. We use T or S, T and S
What's
instead of
S? What does S stand for?
S stands for standard deviation.
Mm-hmm. So we're not given sigma, but can we calculate standard deviation?
Yeah. No. No, we can't. It's
Why
given to,
not?
it's always given to us, right?
Only if it's sigma. That's why we had this chat a few lessons ago, how I want to separate, into the variables and stuff. Because sigma is standard deviation for the population. Standard deviation, or S, is standard deviation for the sample. And we have the entire sample, so we can calculate the standard deviation for the sample.
Okay.
So if you try and do it by hand, because you have 21 numbers there, 20 numbers there, no, 21, it's going to take you a while. Do you remember how to do standard deviation on Excel?
Excel, yes. We do equal to STDV or EV.
And there's actually two different ones that I'll give you options for. So you got stdev.p or .s, and .p is obviously for population, so we want the stdev.s for our sample.
Oh, I didn't know that. Okay, wait. Let me write that down. So for the sample, standard deviation, it's STDEV dot S.
Yes.
Okay, let me get Excel up. Sorry.
Oh, no problem. It's also given, I just want to encourage you to, get the hang of Excel and stuff, but it's
Yeah.
also given on that quantitative inference procedures sheet that you're able to download. So that automatically calculated it for you once you put your numbers in.
Oh, it totally did. Is it 36.356?
Mm-hmm.
Oh, well, that's easy, isn't it? Okay.
But yeah, like I said, I like working with blank sheets of Excel. That way it just forces me to memorize the equations. That
Yeah.
way, like if I ever, if I forget to save this sheet or for some reason it won't open or I can't download it or anything like that, I have the equations memorized, so then I can just do it on my own. So I encourage you to do that, but obviously whichever way helps you the best, do that because you don't want to be sinking any more time into this class than you absolutely need to.
It's I feel like I'm learning Excel more and more, and it's really kind of opened my eyes to how much Excel can do. And it's like a really awesome tool.
But there's only so much you can learn at a time when you're learning stats on top of it.
Yeah.
So
Yeah.
learn what you can, but
Totally.
definitely use a crutch if you need it. You know.
Okay. So the standard deviation is, and I actually did this in Excel to see if I could do it, and I
Oh,
did.
perfect.
And I got 36.3558.
Yes, that's what I got. Excel gives you a little bit more precise than what the quantitative inference procedures gave. So you got the right standard deviation. So we've got the mean, the standard deviation, the sample size, the degrees of freedom, and our t-score. So we should be able to get our margin of error and then just add and subtract that from our mean.
Okay, so margin of error is going to be mm-hmm. And for our t-score, it's 0.006, right?
Our t-score, if you remember, so
Oh,
we did degrees of freedom of 20. Then we highlighted the left and right wings of the graph, and then typed in an area of 0.05.
so, oh, sorry. So it's 2.086.
Perfect.
Do we use a negative though, right?
Honestly, it doesn't matter because you're adding and subtracting. So you're going to be ending up using a positive and a negative z-score. I always just use the positive though because, for example, I'll just show you real quick. On my Excel sheets, oops, not that one. On my Excel sheets, I just label it lower limit and upper limit. And so the lower limit is obviously going to be minus, and then the upper limit is going to be plus. I got that ugly, dang it. Okay, but yeah, so that's going to be negative, that's going to be minus it, that's going to be plus it. So it honestly doesn't matter. It's just that, and you're even going to get the same scores. I just like using a positive z-score just for the sake of simplicity.
Okay. So,
I just like to
question.
keep things organized like that.
Yeah. So 15 is the answer negative 2.086 or is it 23.499?
Wait, question 15?
Yeah.
Question 15. Okay. Well, what were the values again?
So on the one sample t test for mean, it gives the confidence interval, and the lower limit is 23.499, and the upper limit is 56.597.
Mm-hmm.
So are those the answers for 15 and 16?
Yeah, it's just like in the last section. What we would do is we would go parentheses. We would go. Why can't I think of the word? What's it called when you hit Shift 9? What's that called? I can't believe I'm drawing a blank on this. That's so dumb. It's not a bracket. It's not, that's so dumb. Parentheses. Yeah, parentheses. Why am I so dumb? Anyway, we'd go parentheses, lower limit, comma, upper limit, close parentheses.
Okay.
And then instead of typing it out in that format, it's just asking what's the lower limit and what's the upper limit.
Okay. Okay, so 15 is 23.499 and 16 is 56.597.
Super close. Read the
Oh,
questions one more time. I
what
actually
is
did
the
this too.
what is the upper limit of this confidence interval?
And read the parentheses.
Round to one to haha.
Yes. So I told you on that last test, make sure you read every single word.
Ah, dang. Okay. So it is actually 23.5 and 56.6.
Yes, perfect.
Cool. Okay. So I will submit. Let's see what we got. We got 100.
Okay, perfect. And this making sense to you? The fact is, it's
Yeah.
honestly, they just threw one extra concept at us. What happens if you don't have sigma? Well, if you don't have sigma, just make sure to explicitly specify what your sample size is, minus one from that, and that gives you your degrees of freedom. And
Mhm.
then plug that into the new app that we got, and then it's exactly the same as what we did on Tuesday. So there's just
Nice.
one new thing. Like I said, like back when I was doing research with BYU and we didn't have this nice app, this one little change changed the whole game. And so
You're
it
like,
was a
it's
huge
horrible.
thing to learn. But no, this lesson from Tuesdays, this is exactly the same lesson. They basically just said they just added one little thing. Well, if you don't have sigma, just use the standard deviation of your sample and make sure to specify um, your degrees of freedom so you know exactly which curve to use.
Yeah.
So
Yeah,
aside
it
from that,
was
it's exactly the same.
yeah, with the app and the Excel sheets they give us, it's pretty easy. It's just pretty much plugging in the numbers, so it's
Yeah.
not too bad.
Yeah, I think I would assume that in the next few years they'll probably just merge these two lessons together because they're so close. Because like I said, a few years ago it was a nightmare, and this was like practically a chapter on itself,
Yeah.
or I'd assume. But yeah, if you feel as this was too easy, then you're right. It's pretty much exactly what we did on Tuesday. So
Yeah.
okay, so
Cool.
you feel good about it?
Yeah, I feel pretty good about it. Yeah.
Okay, perfect. Then just remember next week,
Monday.
Monday. Yes.
Okay. Cool.
Okay, then I will see you. Have a good weekend.
Cool, you too.
Okay, bye.
Bye.